Okay, so we want to identify the critical points and determine the local extreme values. So first thing we want to consider, if you look at the domain here, the domain, since it's less than or equal to 1 and greater than 1, it's all real. So we have no endpoints. So what we want to consider is where is the derivative, where is this equal to 0, and where is the derivative undefined. Okay, so first we'll look at where is it equal to 0. Now since I have two portions here, if I do the derivative, let's look at the first part here. So the derivative of x, we get a negative 4x. So if we set that equal to 0, we get x equals 0, and that actually is in that part of the domain. So we have a critical point at x equals 0. If you try to solve the other one for the derivative, you get f prime of x equals to 1. That's not going to work. So this other piece isn't going to give us, which makes sense, because if you think of this in y equals mx plus b, y equals x plus 2, it wouldn't have a horizontal tangent. So then we want to consider also where is it undefined. Since this is a piecewise function, we look for a corner. If there is a corner, then that is one location where there's no derivative, or the derivative is undefined. So I'm going to look at the derivative of, let's do the derivative of 1 from the left. So since we found the derivative was negative 4x, it's negative 4 times 1. We get negative 4. The derivative from the right, well, that's just going to be 1. So there is a corner. So that means we also have a critical point at x equals 1. So we have two critical points, 0 and 1. Okay, so we can plug in f of 0. F of 0 we have to plug into the first part, so that becomes 5. And f of 1 is 3. So I'm just going to verify with one of these number lines. So at 0 and at 1, so I'm going to check to the left of 0, say negative 1. So when I plug in negative 1, I get positive. Okay. So when I plug in, let's say negative 1 to the derivative, I get positive. Let's say I plug in a half, we get negative, and if I plug in something bigger than 1, we still get a negative. Actually, bigger than 1, we get 1, so actually that's positive. So it goes up, then it goes back down, then it goes up. So basically here is a maximum, and here is a minimum. So at 0, so we have a maximum is equal to 5 at x equals 0, and we had a minimum that's equal to 3 at x equals 1.